It's not changing. Yeah, now it's changing. Yes. So sensory memory, as I said, that it holds information derives from the sense organs that less than a second after an item is perceived. Like, this is iconic, like, through eyes, echoic through ears, and haptic through touch. Whereas sensory short-term memory, there is a capacity for holding small amount of information for duration is estimated to be is a matter of seconds. Whereas long-term memory is for long-term storage. Like you see, I opened my box and closed it. That is a short-term memory. I may keep it or I may not keep it. But you see, I need to take a bus to go to my college. That I remember for every day. That is a long-term memory. I know the bus numbers. So in that way, different types of memories are there. And long-term memory, that types of long-term memories are like explicit memory. That memory is consciously available. How it is consciously available? Like it is episodic, that memory is a specific event in time and supporting of their information retrieval. For example, someone's name. If I see someone's face, I remember the name, remember the face. Whereas autobiographical, if I have a nice story with my friends to share, that is autobiographical. Whereas semantic, that is a knowledge about the formation, that is the like words. I am formulating some words, that is semantic. Whereas implicit, it is unconsciously happened. Like some of you already know, and you will know that Pavlov did an experiment. When Sir Pavlov used to give food to the dog, he used to ring a bell. And when he used to ring a bell, the saliva used to be secreted from the mouth of the dog. But later, after a few days, he didn't give food, but he only rang the bell. So the dog heard that through its ears and can respond to that. Even there is no food, the saliva was secreted. So that is an implicit memory. So these are the types of long-term memory. And the memory now, like different region of the brain, as I mentioned, that in the brain there are different regions which are responsible for different types of memories. So you know from a neuroanatomic distribution, amygdala is emotional and episodic memory. Like see, if I see a movie which is very romantic, I keep it in my memory, I get happy. At the same time, there is a very sad story, tears comes on my mind. Whenever this movie goes, the tears will come. So this is called emotional and episodic memory. And hippocampus keeps the declarative memory, cerebellum keeps the procedural memory, and that is entorhinal cortex keeps the episodic and semantic memory, and basal ganglia keeps the procedural memory. So as they have defined regions, amygdala, entorhinal cortex, cerebellum, hippocampus, my talk will be mainly focusing on hippocampal region, that because hippocampus is one of the important region where all the information comes and memory is processed. So let us see where is the hippocampus. So hippocampus is located deep within the temporal lobe. As I said, we have frontal lobe, parietal lobe, occipital lobe, temporal lobe, and limbic lobe. So it is deep within the temporal lobe. You can see it here, and you can see this is a paired organ, and parts of the limbic system also associated, because when limbic system is damaged, memory also gets hampered. That's what limbic system is also associated. And the paired organ looks like the seahorse. The name of the seahorse is called hippocampus. That's what the name was given. The region is hippocampus. So function includes formation of the new memories, memory consolidation, and spatial navigation. So now, here you can see that different types of memories will be formed, but they will come from different sense organs. Like you can see here, the visual information, the color of the dress, facial expression will go through the visual cortex, and then somatosensory cortex, cold temperature, then auditory cortex, that olfactory information, smell of the food, and auditory cortex, the persons can sing. All these informations, you can see, they will be going to the hippocampal, the paired region, and will be processed. And that's what hippocampus is, the region where memory can be processed and consolidated. And here, if I take into further, you can see this is actually step 2, the memory consolidation happens. In memory consolidation, there are short-term memory, which goes for long-term memory. So strength of the neural connections are very important here. Like some people can ask the question, how memory is stored? So you can see when neuron gets fired, neuron secretes some neurosecretory materials, and they actually helps to form the short-term memory. And then recalling and remembering. As they recall more and more, and they remember more and more, it goes to long-term memory. So what happens? The neurosecretory materials will come, and they will bind to the postsynaptic density region receptors, and they will be converted to long-term memory. So short-term memory is a part of presynaptic neuron, and long-term memory is a connection between short-term memory and the postsynaptic density region. So long-term memory actually goes for postsynaptic synaptic plasticity. So what happens when the neurosecretory material comes? These neurosecretory materials, they are coming due to the neuron firing. They are released from the neurosecretory vesicles, and when they come, they will bind to the postsynaptic density region, and new proteins will be synthesized, and new connections will be formed, and that gives the long-term potentiation. But if, say, short-term memory is here, but they do not need to keep it in long-term memory, then it will be withdrawn. That is called long-term depression, or long-term potentiation, opposite to long-term potentiation. So synaptic plasticity will happen, and here you can see that will form the more and more neuronal connection, and that is basically the formation of the neuronal network. So now in the neuronal network, how it forms? So this is the parahippocampal gyrus. You can see here from the entorhinal cortex, they will go to the mossy fiber to the dentate gyrus. From the dentate gyrus, they will go as a bundle to the CA1 and CA3 neurons. From CA3 neurons, they will come to CA1 neurons, and they will form to the subiculum, and then it will be processed. So hippocampus formation is involved into trisynaptic circuits. So long-term potentiation, how it happens? I will give an example of glutamatergic neurons of the hippocampus. So you can see here, this is neuron is fired, and the neurosecretory vesicles are secreting neurosecretory materials. They are binding to the AMPA receptor, and due to the AMPA receptor, there is a, like sodium is coming in, there is a small depolarization current is formed. But what will happen, that if there is a strong or repeated signals are coming, then they will finish binding to the sodium, and sodium will come in, and as there are more sodium, they will bind to the magnesium due to the positive polarity, and then the magnesium will open, then there will be channel is opened, and more sodium will come in, calcium will come in, and they will give the long-term potentiation. So what will happen in the postsynaptic resting area, AMPA receptors actually is involved. There is a PKC formation or CAM kinase 1, whereas in long-term potentiation, there is a NF-kappa B, and there are CERB is there. So this CERB is a transcription factor which binds there, and it amplifies the signal, and the signal will form the long-term potentiation. So now this is about the memory formation in the hippocampal region and memory, how it is processed. That's what all the informations will be there in the memory region, in the hippocampal region, and it will be consolidated. You heard from several lectures like, that in some diseases memory gets lost, memory losing disease, and you will hear from me some of the neurological disease where memory is not a direct effect. But due to that disease, there is a memory loss can happen, like Alzheimer's, Parkinson's, multiple sclerosis. But before that, I want to tell you that how memory can be affected. Because memory, when they form, they can also be affected due to our health condition. So what are the factors? These factors are, you can see there can be intrinsic factors, which are age, maturity, medical conditions, emotional factors, and there is a rest and sleep. These are intrinsic factors. And there are some extrinsic factors. Among these extrinsic factors, there are like meaningful materials, and about the materials, and there is a discrimination, there is a strong activity, and there is a impaired activity also. So these are extrinsic factors, like when it comes from the outside, and these will come from the inside. So brain has, any neurodegenerative disease has two types. One is cell autonomous, one is cell non-autonomous. What happens in cell autonomous? Like some factors which are present within the cell, and that factors actually causes the disease. That is called that cell autonomous. Some of the proteins like A-beta peptide, alpha-synuclein, these are CAG repeats, these are neurons' intrinsic properties. But these intrinsic properties can get affected due to some disease. And that time it is called cell autonomous. But if there is a viral challenge or there is a trauma, then this is called non-autonomous. So we will be mainly talking about the cell autonomous, and my talk will be mainly focused on the medical condition, like when the memory get affected. So here I can show you that progressive loss of the structure of the function of neurons ultimately causes cell death. And if there is a neuronal cell body gets affected, then this is called neurodegenerative disease. But if cell body is intact, but there are alteration in the other parts, like axon gets damaged or myelin gets damaged, this is called neurological disease. Examples are amyotrophic lateral sclerosis, multiple sclerosis, Parkinson's disease, Alzheimer's disease, Huntington disease, multiple sclerosis, and multiple system atrophy, as well as prion diseases. And to make a note that specifically, like none of the specifically on memory, instead memory loss is often a causative of generalized neuronal dysfunction. If there is a generalized neuronal dysfunction, then memory loss can happen. The billions of neurons which are connected, they actually get lost, or there is a death, and that affects the memory. So I will be mainly talking about Alzheimer's disease, Parkinson's disease, and multiple sclerosis. And multiple sclerosis, I work in an experimental mouse model which mimics certain pathology of human neurological disease, multiple sclerosis. So you will hear from me about the experimental animal model also, where we do not study as such memory, but we try to understand what happens when virus enters into the brain and how it affects the neuronal circuits, how it causes the neuronal death, astroglial death, and that can affect memory. So first let me dissect out what is Alzheimer's disease. So Alzheimer's disease, in our brain there is a protein, it's called A-beta peptide, which is very much important for neuronal repair. And that protein has a normal function. In normal brain, what happens? There is a alpha secretase and gamma secretase. They cleave the protein into, and that forms the soluble degraded protein. And this protein is important for neuronal health. But, in normal condition, that's happened. But in diseased condition, there is another one, that is the beta secretase. When beta secretase come, this enzyme cleaves the protein in different regions and can cause insoluble aggregates. And when this protein gets aggregated, they form the neuronal plaque. And this plaque formation is abnormal to neuron. So now you can see in between the neuron, there is a plaque formation. And this plaque formation actually causes the disruption of the microtubules. So in a normal healthy brain, the microtubules are aligned properly through the axon. But here what happens? Through the axon and the neurofilament, the neurofibrillary plaques, plaques comes, and these plaques causes alteration of the transport of the tau protein, which is also another protein involved in the microtubule associated protein. This protein gets degraded, actually it gets hyperphosphorylated, and then they form the tangle. So there is a plaque formation, and plaque formation actually induces the hyperphosphorylation of tau protein, which forms tangles. And these plaques and tangles starts to form the entorhinal cortex and hippocampal formations, and later spreading into the other temporal, parietal, and finally frontal association cortex. That's what memory loss happens. So what happens? Plaque disrupt communication between brain cells and interfere with the normal functioning of the neural network. So they come in between, and the normal network, like the action potential comes and they goes to the synaptic terminal, the neurosecretory material secreted, the neurosecretory materials helps to bind to the postsynaptic density region, but as plaque is formed, these neurosecretory materials may be secreted but cannot bind to the postsynaptic density region. That's what the plaque actually causes, discontinuous action potential propagation. And that's what this plaque disrupt communication between brain cells and interfere with normal functioning of the neural network. Whereas tau protein becomes tangled and impair the transport of nutrients and other essential substances within the cells, and that actually contribute to memory loss and cognitive decline. And there is a disruption of the levels of the neurotransmission. So you can see here, as I mentioned, the plaque is formed here, neurofibrillary tangle is formed there, so they cannot propagate the action potential properly. If action potential is not propagated at the nerve end, they cannot release the neurosecretory materials at the nerve end. Even they secrete it, if there is a plaque, they cannot bind to the postsynaptic density region, and in that case, no nerve impulse can be transmitted, and that actually reflected in the memory. And that is basically acetylcholinergic nerve causes this type of plaque formation and memory loss. So what happens? There is Alzheimer's disease. When the plaque is formed, there is a mitochondrial dysfunction and inflammation happens. Of course, there is the accumulation of the foreign protein, not foreign protein, Alzheimer A beta peptide is aggregated, and that forms inflammation, and there is a oxidative stress. Due to age also, oxidative stress can happen. That's what you can see nowadays. A large number of people get Alzheimer's, and it is a very much warning that we get lots of age due to medication, like people live more than 80, 85, 90. But if you see during our independence time, the average age limit was 45. So people was never showed any neurological problem, or they didn't show like Alzheimer, memory loss. But nowadays, lots of people develop this disease, and it is really alarming. So we have to be careful, we have to do our exercise. We have to keep doing eating healthy food, so there is no oxidative stress. stress is developed, because oxidative stress, if it is developed, build up, it's believed to play a role in the progression of the disease and contribute to the memory loss in Alzheimer's. And a significant loss happens due to sympathetic connection leads to breakdown of communication between brain cells, as you can see, between two neurons, and astrocytes are in the periphery of these neurons. Astrocytes helps in mopping the neurosecretory materials, but that time astrocytes cannot function also, and this disruption disrupt memory consolidation and material retrieval process. So there the end process is memory loss. So that is basically about the Alzheimer's disease, how it impacted the memory formation. Then there is another disease, which is Parkinson's disease. You might have seen like some older people develop that, and actually it starts from age 55, then it goes to develop more and more, and people have tremor, people cannot, their limbs cannot function properly. So that happens due to dopaminergic neurons in the substantia nigra generally die, and that gives the disease. So what happens, the main job of the basal ganglia is to coordinate movement. And how they coordinate movement? By direct pathway or by indirect pathway, from the striatum to globus pallidus and subthalamic nuclei and substantia nigra. So they uses excitatory neuron, they also uses inhibitory neurons, and the interaction between excitatory neurons and inhibitory neurons help people to move, or there are no movement. So slowly this gets degenerated because there is the accumulation of a protein which is alpha-synuclein. When alpha-synuclein aggregates in the substantia nigra, then the connection is lost, and that time it forms the tremor. So let us see in direct pathway what happens. The motor cortex gives the excitatory signal to striatum. Striatum gives inhibitory signal to globus pallidus, internus, and substantia nigra. And substantia nigra cannot give any more signal, so it is a negative signal to thalamus. But instead of negative signal, thalamus provides the positive signal to the motor cortex, and the end effect is movement. But in indirect pathway, what happens? Motor cortex gives excitatory signal to striatum, but striatum gives inhibitory signal to globus pallidus externus and subthalamic nuclei, whereas all through there is a negative signal, but this negative signal comes as a positive signal to thalamus, but motor cortex cannot help to move. So there is no movement. So generally what happens? Substantia nigra, dopamine is secreted, dopamine gives the excitatory signal to striatum and stimulates direct pathway and inhibits indirect pathway. That's what, due to the inhibition of indirect pathway and excitation of the excitatory pathway, like they move. So that's what you can see in Parkinson's disease. People slowly have some problem in extreme organs, and slowly they go to cane, then they go to that chairs, and then they go to wheelchairs. So what happens here? Dopaminergic neuron in the substantia nigra gradually die, and less stimulation of the direct pathway and more stimulation of the indirect pathway, and overall reflection is that is reduction of the movement. That's what happens in Parkinson's disease. But from the cellular aspect, if we look at it, what happens at the cellular level? In the substantia nigra, there is a protein called alpha-synuclein. This alpha-synuclein gets aggregated, and they form the Lewy body inside the neuron, and Lewy body formation causes inhibition of the excitatory signal to go through, and together they do not allow neuron to communicate to each other. And as an effect, what we see, tremor, stiffness, difficulty in walking, cognition, and memory loss. These are the effect of Parkinsonian disease. And Parkinsonian disease has a cognitive impairment also. This Lewy body, as I said, alpha-synuclein, can affect multiple brain regions involved in memory, including the hippocampus, which is crucial for formation and consolidation of memory that we already dissected out. And Lewy body is in substantia nigra, that can be stained, and you can see this is brown color is the Lewy body, and this Lewy body can affect multiple brain regions. And it reduction of dopamine level, so L-dopa comes, L-dopa goes to dopamine, but if there is a restriction in here that L-dopa cannot convert it to dopamine. So reduction of dopamine level in the brain can contribute to memory impairment, and that affect memory process, including emotion consolidation and retrieval of encoding, the consolidation and retrieval of information. And as a cause, what happens? That is a PD may import the medication of the PDs also. Like when people take the medication for Parkinson's disease, there are lots of side effects. One of the side effects is memory loss due to the lack of dopamine. So while this is about Alzheimer's disease and the Parkinson's disease, multiple sclerosis is one of the neurological disease. It is a big question whether we will add it as a neurodegenerative disease or we will keep them in neurological disease. Because depending on the etiology, how the disease is caused and what are the factors, it can be classified as neurodegenerative disease, but in most of the cases, we call them as neurological disease. What happens? It is one of the main disease, neurodegenerative inflammatory autoimmune disease, predominantly white matter disease of the CNS, including brain, spinal cord, and optic nerves. And myelin sheath degenerates, causing demyelination, adds impedance to nerve impulse in process. So what happened, the neuron has a cell body, a neuron has axon. The axon in most of the motor neurons, axon is myelinated. What is there? There is a cholesterol and there are lipids. They actually proteolipid protein form